We will have two speakers for this presentation. The first one is Barbaro. Barbara is an underwater archaeologist. Hello, ciao Barbara. The Ministry of Culture. She is the head of the quality service of cataloging process at the Central Institute for Catalog and Documentation of the Ministry of Culture. And then we will have Marco Medici, that is assistant professor at the University of Ferrara, Department of Architecture. So, Barbara, take the floor. I've seen this morning from Facebook that you had some great news from this site that you are talking, that you are going to talk. So, it would be a pleasure to have you also with this new news.
Thank you. So, I share my screen.
Put the presentation in full screen.
Yes. It's okay.
Perfect.
So, good morning, everyone, and thanks for participating. And today we present an innovative system for the participatory production and return of data and images relating to the underwater cultural heritage, which has been tested and developed by the Central Institute for Cataloguing and Documentation and the Archaeological Superintendence of Southern Etruria in a pilot project involving the archaeological area of early Iron Age site named Gran Carro of Bolsena. The project was carried out in agreement with the University of Ferrara. Marco Medici will speak after me. And the underwater operations were carried out in close collaboration with the archaeologists and divers of Underwater Archaeology Research Center, APS. The Gran Carro settlement is principally dating on the late 10th, 9th century BC and correspond in Italy to the Villanovian culture. The site is unique for its state of conservation among the pile-dwelling settlements in Italy, and it certainly represents one of the most important discoveries that took place at the end of the 1950s. It's currently submerged halfway along the eastern coast of the Bolsena Lake, and it is the first protohistoric deposit identified in the inland waters of peninsular Italy. Since 1960 to 1980, the site has been the subject of studies and researches based on the analysis of surface data as well as topographical readings. During this period, the settlement was also subject of numerous excavation campaigns during which a large number of poles were identified and more than 4,500 intact ceramic finds were discovered. Among 2012, the research restarted using new techniques of reliefs, employing tools as the phototechnograph that allows to perform a 3D restitution of the excavated layers. Until 2019, the excavation operations were concentrated exclusively in the area of the pile dwellings, which is characterized by the presence of over 490 still well-preserved piles on the lake bed. You see in the slide. Between 2020 and 2021, the superintendent has planned extensive survey activities in the area of the settlement aimed for submitting the site to archaeological protection by legislative decree. This circumstance made it possible to discover for the first time other areas occupied during the early Iron Age, bringing the occupied surface from 800 square meters to at least 1.5 hectares. During the survey, it has been also possible to understand for the first time that the so-called Aiola was also part of the proto-historical settlement, a monumental elliptical structure of 60 for 80 meters in pieces of stone, visible also from the aerial views, probably connected to the presence of thermal springs used until Roman period. The documentation and positioning of the archaeological complex was thus carried out. Start from photographs through software processing, we obtained three-dimensional models for all the sector, all the square, and many of the excavation levels in the area of the pile dwelling, but also in some other areas of the settlements. The goal is to have a complete documentation by the end of the 2021. The results of photo restitution allowed us to reconstruct the living sequence of settlements, and below we see some examples of 3D models, plan or perspective. Here we can see the sector 1, the area, the pile of the pile dwelling. Here several squares also in the pile dwelling area. Here we see some details of the square C1 in the pile dwelling area also. And now I show you a short 3D animation of C1 square, the only one where we got to the bottom of the deposit. You can see vessels and wood remains. Okay, and you can see the sector 4 in the southwest area of the Aiola, in which wooden remains up to 5 meters long have been identified. You can see in the slide. And here we have the sector 2 in the northwest area of the Aiola, where areas with concentration of dolian and wood have been identified. So, we are also creating 3D models of many of vessels often found completely intact. And here you can see some examples. But after the excavation, we are therefore proceeding to catalog all the archaeological finds and structures found. Under the existing Italian legislation, the ICCD serves as the coordinating agency for the definition on procedures and instruments for catalogation and documentation of the cultural heritage. The Central Institute for Cataloguing and Documentation defines standards, methodologies, and procedures for cataloging according to the homogeneous criteria. The General Catalogue of Cultural Heritage is formed and managed by ICCD through the CIGEC web platform, which is an ICCD proprietary information system developed to control and manage the process of cataloging and represents the most effective working tool to guarantee the identification of assets, the quality and updating of information, as well as a safe method for integrated data management as a unitary and transversal information system among different types of assets, different subjects, and territorial contexts. Two different types of catalog sheets, the archaeological site, the excavation sector, the individual finds, the remains from the Gran Carro have been so catalogued according to the ICCD standards in the CIGEC web, where all the catalog sheets are also related to each other through an advanced systems of relationship. Here we have some examples of catalog sheets prints, site, sector, square, and finds. Now, how to combine the 3D models with the information contained in the catalog sheets? Starting from 2017, ICCD published the catalog data in linked open data according to the ARCO ontologies network. In 2020, the new catalog website is published entirely based on linked open data. The philosophy of linked open data is based on the idea of using every resource available online and connecting them through mechanism of similarity or equality, facilitating the expansion of the information. So, the ICCD enhanced data of cultural heritage, correlation of data on the web and for the web, making the general catalog as a knowledge graph of the cultural heritage. Linked open data are stored in a RDF trial store accessible by everyone. You see in the website dati.beniculturali.it. In this way, all catalog data can be interrogated through customized Spark queries, and furthermore, any data can be linked by any application, for example, Inception. So, Marco Medici is going to present the Inception. Okay.
Okay, thank you. Thank you.
And I ask, okay.
Okay, thank you, Barbara. I'll take it from here. And yes, the main question that you just asked to everyone, how to merge two different stuff like 3D models and semantic web, is actually the main question of this research. So let's talk just a bit about the Inception project that was funded between 2015 and 2019 under the Horizon 2020 program. It was basically more focused on buildings and monuments rather than on archaeological sites, but we tried to use the same approach and use it for the archaeological purpose. Right now, there is a small startup company, spin-off the University of Ferrara, that is bringing on the development of this original platform. So, as Barbara said, how to merge this kind of models. But let's talk also about how 3D models are created. So if we focus on 3D models that we have seen today, there are a lot of them and wonderful examples. Most of the time we have 3D models from structure from motion techniques that are basically a bunch of triangles with a texture on it. They are perfect for describing a three-dimensional element, but at the same time, if we want to integrate into them information, it could be quite tricky. There are several formats that can merge three-dimensional information with textual information and contextual infos, but at the same time, most of the time they are missing some information about textures, about the real appearance. In this case, we are using building information technologies, an adaptation of them. So on the screen, you can see how the same model appears if we are looking at it like a mesh model with textures, or if we look at it like a mesh models, an IFC model that is basically the standard from the for BIM formats with information attached to them. But also, as Barbara said, we do not have only the three-dimensional models of the excavation, the underwater excavation, but we have also wonderful models of the finds. So how to bring them together in a unique environment and how to ensure the correlation with the catalog of the CCD. And this is possible only because everything is based on semantic data. So we are basically, in this case, providing the CCD with this platform that is managing three-dimensional objects into a semantic way. The platform can overlap 3D models with the information models, and make every element selectable and linkable to single 3D models representing the finds. At the same time, with Sparkle queries, live queries from the semantic web endpoint provided by the CCD, we can retrieve information and attach them in a live way to the object. So in order to show you better how we did that, I prepared a kind of live demo. I mean, it's a quasi-live demo because I just recorded my screen in order to show you what we can do. So basically, in this case, we have an online platform in which we have several categories. As you have seen, there are not only archaeological sites, and we also have a geographic search. So you can navigate on a Google map or an OpenStreetMaps or whatever, and find the exact location that you are looking for, or you can go by categories. So in this case, let's jump into the archaeological sites category. In this case, okay, it's a kind of a demo, so we have just 5 models of the site, of the sector, and 3 models of the excavation, the square excavation underground. So in this case, we have the 3D model of the entire site, or at least a part of it, because it's still a survey that is ongoing, so we do not have everything. As you can see, we can move and we can merge with different levels the 3D models, so you can switch from the texture one to the more technical one. You can go full screen, so this is an online environment, so you just need a web browser to go into that, and you can navigate the 3D model. So it's not so different from a traditional 3D web viewer, but in this specific case, what you can do is just select elements. So the technical model was segmented, and so you can select single elements and retrieve information on them. So let's make the example of the Aiola. In this case, we do not have a 3D models that is representing the specific part, but at the same time, we can have the name of that element with the same name that we have on, with the unique reference identifier that we have also on the catalog. And here we can navigate the metadata connected to this element. So in this case, we have the date, we have the description, the identifier, and whatever is directly retrieved from the cataloging system provided by CCD. At the same time, we have a live link in order to go directly on the page dati.beniculturali.it, on which you can see directly how the information were archived. Or you can also have a specific button that is now called for this purpose eCCD, and you are just retrieving all the information directly on the page of this specific platform. So in this case, you can show how information, pictures, and whatever is stored on the catalog can be inherited inside this specific platform. But at the same time, we do not have only elements that are 3-dimensional elements and are in there, but we have also live connection in order to explore the hierarchical relationship between sectors, between sites, sectors, and squares, as Barbara was saying. So in this specific case, we have once again all the description and all the data coming from the catalog, but at the same time, we have a new property inside the metadata that is called inception link. And in this case, you can jump to the sector 1 Gran Carro. So let's jump to the other video. So in this case, you can navigate the sector 1. In this case, we have just a plane with a texture on it because we are still working on the 3-dimensional models of this part, but yet we can still use it for demonstrating how we can navigate it even without having a proper 3D model. So in this case, we are selecting the square C1, the one that Barbara was showing before, and even in this case, we have the live information about the C1, so we do not have to store on our platform any kind of information. We are retrieving them with a Sparkle query from the catalog. And in specific case, we have 3 links, not only one, because we could have 7 links, but in this case we just put there just 2 links. And in this case, we can go to the specific square in which we have different levels. So in this case, we are once again on the level 2, and you can navigate also this single part of the excavation. And as you can see, you do not have only the 3-dimensional models, but you have also 2 placeholders. These 2 placeholders are related to finds that are coming from the excavation, but they are not mapped inside the 3-dimensional models. So you need to select them using placeholders, since they are still referred to this specific square. So in this case, okay, the video is still running. So in this case, you also have a button that is called attachments, in which that you can use in order to select all the elements that have specific attachments inside the 3D environment. And those specific elements are basically defined. So for each element, you can select it, retrieve the metadata, still coming from the ICCD catalog, but at the same time, you can also navigate the 3-dimensional model related to that specific element. So, okay, yeah, still we can just jump a little bit farther in the video. So here you have still the documentation from the ICCD catalog. But if I jump a little bit farther on the video, you have just this part here in which you have the attachment. So the attachment is still a 3-dimensional model that is referred to this specific placeholder. So if I click on the specific link, that is automatically highlighted because of this small I, so you have a kind of bidirectional connection between the attachment with the 3-dimensional model of the square. You can still have the 3-dimensional model of a specific find. So high-grade solution images, a little bit decimated textures, triangles, in order to show it in a little bit more smoothy way online, so you can easily navigate it and having an idea of what we found underwater. So in this way, you can still using the same connection that you have on the catalog sheets, but at the same time, you can also ensure the user with a navigation into a 3-dimensional environment that give you a more, let's say, effective navigation of the 3D environment. So basically, this was what we have done. Of course, we did it for different levels, but for the aim of this demo, I think that could be quite enough to show you what we did for just one level. And so we have several elements. I could go further on for more minutes, but I think we are just running out of time. So I would like just to thank you for your attention, and that's all from my side.
Thanks a lot. Thanks you very much, Marco and Barbara, for your nice presentation. So now we have concluded the presentation. We will have some minutes for the question that we have